I will convince you in a moment that colors do not exist in real world. They exist only in your mind. You don't believe me? Let's play a game with you. Don't worry, your screen is absolutely fine. Look at the black dot in the picture. Please don't look anywhere in the picture. Focus on the dot. The dot is now the whole world for you. Something amazing is going to happen. In a moment, I will change the picture. But don't change your focus from the dot, whatever happened with the picture. Okay? Start. Now with the count of 3, the picture will be changed. 3, 2, 1. Can you see a colorful picture? Now look at the other part of the picture. What are you seeing? A black and white picture. Trust me, I did not change the picture from color to black and white. It was black and white all the time. The colors you have been seeing were never in the picture. Actually, it is your brain who does the trick to you. But how do our eyes see colors when there is no color? In this video, we will know the reason behind this illusion and understand how our brains perceive color. I am Ramanuj and you are watching Slice of Science. Technically, light does not have any color. Instead, it has frequency and wavelength. Why? Because light is a wave, a special wave called electromagnetic wave. It is a combination of electric wave and magnetic wave. Unlike other waves like sound wave or ocean wave, electromagnetic wave does not need any medium to propagate. It can travel through vacuum. But like every wave, electromagnetic wave also has two characteristics, which are frequency and wavelength. A full wave has one peak called crest and one valley called trough. The distance between two crests is called wavelength, and the number of complete wave occurred in 1 second is called frequency. The wavelength is measured in meter and the frequency is measured in hertz, which is the technical word for number of waves per second. So 5 hertz means 5 waves per second. The frequency and wavelength are inversely related because the less your wavelength is, the more wave you can create in 1 second. The full spectrum of electromagnetic wave varies from 10 Hz to 10 to the power 24 Hz. But our eyes can detect only a portion of it, which we call visible light. The frequency of the visible light is 4 into 10 to the power 14 Hz to 7.9 into 10 to the power 14 Hz. But why only this part, not the full spectrum? The answer lies in our evolution. Our ancestral initially evolved in the water, and now we know that the waves of this frequency range can travel easily in the water than the other waves in the spectrum. And moreover, this is the part of the spectrum which the sun emits the most. When one of those visible frequency waves comes from any object and enters the eye through the pupil, it gets refracted, which is a fancy word for bending, by the lens located behind the pupil and creates a real image on the screen called retina, which is at the back of our eyes. The retina is made of millions of light sensitive cells called rod cells and cone cells. The rod cells sense how bright or dim the light is, and the cone cells sense the frequency of the light. There are 3 types of cone cells. The first type senses the smaller frequency light. The second type senses the medium frequency light, and the third type senses the larger frequency light. Together, they analyze the light image and turned it into electric signals. Then through the optic nerves, the signals are sent to the visual cortex of the brain, which is at the back of our head. Now the real magic happens when the signals are interpreted in the brain. Human brain cannot measure the frequency of the light. Instead, it interprets the frequency as color. The light with smaller frequencies like 400 to 480 terahertz interpreted as red color. The medium frequency like 530 to 600 terahertz are interpreted as green, and the larger frequencies like 670 to 790 terahertz are interpreted as blue. So basically the cone cells do not know the color of the light. They only know the frequency. But for our purpose, we will call them as red cone, green cone and blue cone according to their frequency sensing ability. But what about the other colors in the spectrum? How do our brains interpret the color other than red, green, blue? Actually, a single frequency of light does not stimulate a single type of cone. More than one type of cone are activated by a particular frequency. This chart shows how a particular frequency of light activates different type of cones. Let's take an example. Yellow light has about 510 terahertz, but our retina has no cone cells of 510 terahertz. When a light of 510 terahertz frequency hits the retina, it stimulates both the red cones and the green cones in a particular ratio, because 510 terahertz is in between red and green frequency. The combined effect of these two red and green stimulations is interpreted as yellow in our brain. In the spectrum, you can see the yellow is in between red and green. All the colors you see in the spectrum are generated in our brain by this mechanism. Now this mechanism can also trick you. If you can mimic the effect of yellow by stimulating red and green cones in the same ratio in which the yellow stimulates the retina, your brain can see yellow even if there is no yellow at all. Let me show you. If I mix red and green light, I will get yellow. The red and the green lights stimulate the red and green cones in the same ratio in which the yellow light stimulates our retina. So our brain, being the smartest organ in the body, could not recognize this stimulation as two lights. Instead, it interprets this as a single yellow light. This technique is called color mixing. By mixing this red, green and blue in different ratio, you can create different colors in your brain. Digital screens are doing this all the time. If you zoom your TV or mobile screen enough, you will see there are only red, green and blue pixels. But they can still produce all the colors in the world by this magical method called color mixing. But can our brain see any color even there is no color? Let's get back to the illusion we started with. Let's play the game again. You know the deal, right? Stare at the dot for a moment. Don't look anywhere in between. Ready? Start. Now you are watching a colorful picture. But the picture is completely black and white. Every time you see this illusion, it feels like magic. But how do our brains see color when there is no such light? So what are complementary colors? According to the Britannica.com, complementary colors are pair of colors which are opposite to each other on the traditional color wheel. If scientifically speaking, complement colors are two colors which when mixed cancel each other out by producing color like white or black. So sometimes they are also called opposite colors. In some standard color wheels, some pair of complementary colors are red and cyan, green and purple, blue and orange. So what is happening in the illusion? When you stare at a color for a long time, the cones which are responsible for that color get tired. And then when the picture is changed into black and white, those cones cannot pull the weight, so they switched off. And the cones of complementary colors turned on. A great act of friendship, isn't it? That's what true friends do in need. I told you that orange and blue are complementary. That's why when you stare reddish orange for a long time and then the image is flipped into black and white, you see blue in that region. Similarly, all the other colors are changed into their complementary colors, and you can see a complete colorful picture for a short period of time. Can you see the black dot? Now keep your focus on the dot like before. I promise, if you don't remove your eyes from the dot, you will see an orange dot circling through the blue dots. Ready? Start. Can you see the orange dot? But obviously there is no orange dot. Now you know that it's your brain that is creating the orange dot. The illusion is called Pac-Man illusion. The illusion was designed by Jeremy Hinton sometimes before 2005. The illusion is created by the combination of three effects named phi phenomena, after image effect, and Troxler effect. The phi phenomena is the optical illusion of perceiving continuous motion between separate objects viewed rapidly in succession. Basically, the dot is not actually moving. The rapid absence of the dots are interpreted as a moving dot by our brain. We have already talked about the after image illusion. When the blue dot disappears, our brain fills the space with its complementary color orange. The Troxler's effect illusion happens when you focus on one point for a long time. The images around the point slowly disappear. I think you will be rethink about the reality you are watching right now. Because the things you are watching are nothing but the images created in your brain. The reality may not be the same outside your brain. In fact, your colors are not the same as my colors. Because our brains are different and they perceive the colors differently. So all of our realities are different from each other. And those differences are the beauty of a growing civilization. Disagreement is the seed of growth. If everyone in a society agrees on everything, then the society will stop growing. Everyone's opinion is correct as long as it is not violating anyone's freedom of expression. It is not that I am right and you are wrong. It is rather I am right and you are right too. Thank you for giving me your valuable time. See you soon. Tata.